Hey everyone. Okay, so we're talking about Newton's third law and action-reaction forces. One of the questions that you were given to ponder is, what is the reaction force to something falling in a gravitational field? And we've talked about that a little bit, but it's pretty tough for people to understand. I mean, getting an action-reaction force pair from a tug of war, like what you saw demonstrated before, is pretty easy to understand. But when you're talking about invisible forces like gravity, for example, it's kind of tough. So this is a demonstration to help you see that in a little more detail. What I've got right here on this scale is this very strong magnet, and I can prove to you that it's a magnet because I have a little paper clip here, and you can see the paper clip will stick onto the magnet, right? There you go. Okay. Now, what I'm going to do is I'm going to take the paper clip and I'm going to connect it onto this little piece of string here. And what we're going to look at is we're going to look at the force that is acting on the magnet as a result of the paper clip pulling on it. Okay, so here's my paper clip right here, and I'm going to maneuver it really close to the magnet. You can see it's attracted to the magnet pretty strongly there. But what I want you to pay attention to is look at the scale down here. Okay, now if I take the paper clip away, what's the reading on the scale? It reads 1.953 pounds. Okay, but as soon as I bring the paper clip close, you can see the paper clip being attracted to the magnet, right? The paper clip is obviously attracted to the magnet right there, right? You can see it. It's all these crazy angles. But look at the reading on the scale. Notice how the magnet appears to get lighter. Now, of course, the weight of the magnet isn't changing. What's changing is the fact that as the magnet pulls the paper clip pulls back on the magnet, right? Action force, magnet pulls paperclip. Reaction, paperclip pulls back on magnet, and that pulls the magnet upwards a little bit off the scale, so the scale reading gets less. And that is how you can see the action-reaction force with sort of invisible forces like magnetism. You can think of gravity the same way, right? You can think of the magnet here as like the Earth, and then you can think of the paperclip as like a person, right? So your weight is the force of gravity that the Earth exerts on you, but then you exert an equal and opposite force of gravity upwards on the Earth. So hopefully that makes sense. All right, go Team Physics.